project, the AI incoming request processing workflow. What this application does in simple terms is taking any incoming customer message, whether it's a complaint, a question, a request for help, or something urgent, automatically figure out what kind of request it is. Once it knows that, it does not just stop there. It actually runs a different set of steps depending on the type of request, almost like how a real support team would handle different situations differently. As you can see on the right side, the system currently supports four types of requests: complaints, general inquiries, service requests, and escalations. And down here you can see the overall flow. A request comes in, gets classified by AI, goes through a workflow, gets a response generated for it, and everything gets logged into the database for tracking. Now we are going to the next step is the processing a single request. We are going to give it a request, and we see how our particular processing performs and what it gives as the output. So we're going to process this request. Okay, here we got the details of the processing request. This is page is where I can test the system with a single customer request. I simply type or paste a message here, message in this place, and click the process request, and behind the scenes this one click triggers the entire pipeline. The AI reads, the classifies the message, decides how urgent it is, runs the right workflow for the type of request, and then generates a professional response, all within a few seconds. Let me show you what actually it looks like once I submit that particular request. Once I have submitted it, so for this request I have entered a real sounding customer complaint. Someone who ordered a product 2 weeks ago still hasn't received it, has already contacted support multiple times with no useful response, so is now demanding an immediate refund. When I click process request, the AI reads this message and classifies it as escalation and urgent. As it with critical urgency is high, and it's 95% confident in that decision. If you look at the reasoning it generally sensible. It picked up on the repeated failed contact attempts and explicit refund demand as signs this needs urgent human attention is needed in this matter. Because of that, the system automatically triggers its escalation workflow. It flags the case for immediate human review, notifies a supervisor, pauses any automatic resolution, and marks it as a critical priority for a real support agent. And finally, it generates a professional, empathetic response acknowledging the issue and confirming it. And this response is generated with the OpenAI API of the DeepSeek. We're gonna take another example. Let's take this example and see how it performs. We're gonna give it that this as our request. Okay, now for this, I tested a simple low stakes question, someone just asking about customer support hours and whether weekend support is available. This time the system classifies it as a journal inquiry with low urgency again, with high confidence, 95%. Notice how differently it handled and compared to the escalation example. Instead of flagging anyone or pausing anything, it goes straight to resolution. It identifies the topic, generates a response, marks the case resolved, and logs it. And the response itself is exactly what you would want: short, friendly, and directly answer the actual question about the support hours without any urgency or apology language from the complaint example. And this shows the system isn't just applying one generic response to everything. It genuinely adapts both the workflow and the tone based on what kind of request it actually is. And this is the professional generated response created for the customer according to the question they have been put. Next comes the batch processing, in which we can upload the CSV file. I have taken the dummy data to check whether it is working or not. It may take a few times, so I'm gonna process it with the help of an image. So here, beyond handling one request, Beyond handling one request, the system also supports batch process. So instead of manually testing request one by one, I can upload a CSV file, or in case load a built-in sample dataset directly from the project's data folder. Here you can see loaded 250 real customer requests, and each are short, friendly, and directly answers the actual question that has been asked. So instead of flagging anyone or pausing anything, it goes straight to resolution. It defines the topic and cases resolved, logs it, and responds itself what you would want. It is short, friendly, and directly answers the actual question. This shows the system isn't just applying it, and rather than it is making use of it. Next one is this beyond. So here you can, I used to validate AI's accuracy. From here, I can run every single request through the entire pipeline automatically. So in this, I've loaded 250 real customer requests. Each customer's name is there. Each customer's name is there, and what are their queries are there. Everything is been loaded here, and this is the final result that has been put down. So before I wrap up, I would like you to give the quick walkthrough, quickly show you how my actual code is behind this. So as you can see, it's not just a black box. This is a classifier. This is a classifier uh, .python file, and one of the core backend files. So when you're looking at here are two functions that run right after the AI returns its classification. The first one is normalize urgency. This one particular normalize urgency, and takes whatever urgency value comes back and makes sure that it maps cleanly to one of the four levels: low, medium, high, or critical. So even if the wording varies slightly, this second function validate and clamp, this second function which is validate and clamp, and uh, it really safety net of the whole system. AI responses aren't always perfectly predictable. So instead of trusting the raw output blindly, this function checks and corrects the request type, the urgency, and the rationale before anything gets passed further down the pipeline. So it's a small piece of code, but it's an important design decision. It means the system stays reliable and predictable, even if the AI itself is occasionally inconsistent. And down here in the terminal, you can see it. I've already pushed it in the GitHub. It has been already pushed in the GitHub, which with a clean commit and history and all the source files properly tracked, ready to anyone to clone and properly run and make use of it. Thank you so much.